this video about CNC version 3.2 I'm demonstrating basic steps of the build process. The basic tools needed to make a copy of the mechanics are a drill press, hacksaws, a caliper, files, vise, metal
Farai
shears,
e dreit nient.
common tools.
Non de nidi, da traget, non d'amor, ni de juvent. Ni de renau, che nas turbatas endurment. Süzün civahu, che nas turbatas endurment. Süzün civahu, non sai e calura fuinat, non sui alegre, mirat, non sui estrati, sui privat. In un puescaut, che nas de nuet fadat, subrim puegaut, che nas de nuet fadat, subrim puegaut, amiga eu disaises, tanto la bici, maiut fes que en plaza di que en pes, in un bencaut, canto normal del francès, dins munus tau, canto normal in francès, dins munus tau, anco la vi e tant la fort, anco la dreit nin mestort, canto la vei ben de fort, un presen jau, quien saiden sur e bella sur, e che mai vau, quien saiden sur e bella sur, e che mai vau, non sai tu e succestau, si esemplar, austire, l'utor che ma, abans mentau, e pesante in carro sai remar, erai tan vau, e pesante in carro sai remar, erai tan vau, batallo verso non sai di qui, e trametrai l'un a sedui, e l'un trametrà per autrui, e vers peitau, che trametes del seu esti, la un traclau, che trametes del seu esti, la un traclau.
Motor oil is a very cheap lubricant for the tool. Every couple of minutes, reverse the movement to break the grips and so the grid thread prevents the tool from jamming. I've moved pieces of wood and screwed them on the table of the drill press before the holes of the angle joints. Never hold the tiny parts by hand, always use the caliper. Two metal sheets are used for the framework, one with bent flaps. With a square tube and two flaps you can bend the metal on your workbench using a hammer. After countless hours, the hardest work is done and you can start the assembly. The screws I am using have a round head for hexagon tools. With that tool you can easily screw the bolts at different places. A couple of parts is the angle joint and you can use a washer only underneath one of the bolts to press the flat head. In principle, split washers are as good or bad as normal washers. It's the correct torque that prevents screws from moving rather than split washers. The thread in the thread loop is no more than 2 millimeters depth, but there is barely more than a single turn. The test sample to find out what torque is a high torque for your material. I made the test by reading the screw head rather than the thread in the thread loop with a good result. First one so that I can bend the frame to make all parts fit. If the frame is assembled, I can also use it on one piece top. That I will of the dimensions 20 x 4 mm, I have added crossbars to make the framework even stiffer. A couple of distance pieces were cut from the flat iron bars to make it all fit in. At the center point, the crossbars are linked through 6mm bolts and nuts. Assembling the carriages for the axis was the next step. Those carriages run along the guides with ball bearings of the dimensions 10x30x9mm. Handmade parts means worse tolerances. To compensate for that, one side of the ball bearings is designed to be pressed on the guides through threads. Adjust the mechanics in such a way that all ball bearings are spinning reliably when moving the carriages, but don't build up too much friction by pressing them too hard on the guiding tubes. It's time consuming but worth the effort to minimize the backlash of the mechanics. As a result, you get a very stiff construction with precise movement along the axis. The rotational movement of the motors is turned into linear movement through 6mm threaded rods. The female thread at the carriage is formed with a heated nut in a stripe of acrylic plastics. After cooling down and grinding the edges, you have an accurately fitting counterpart for the threaded rod. The drilling is done after aligning the plastic stripe correctly and marking the hole positions. A second stripe with the female thread is needed to move the axis. The lower half is screwed at the carriage. The upper half is pressed on the threaded rod using two coil springs from an old printer. With that you get a low backlash linkage between carriage and the threaded rod. Once more there is, too much pressure results in too high friction, not enough pressure results in unwanted backlash. With the spring coils, the wear on the female thread is compensated. You can also use pieces of rubber tube instead of the spring coils. Use lubricant to reduce friction and so wear on the threads. The threaded rod is linked with the mechanics using two ball bearings. Those bearings are pressed on a square tube using nuts. You already know how to adjust, no more pressure than needed and enough to get a tight linkage that is free from noticeable backlash. Too much pressure results in too high friction. Furthermore, there is too much wear on the ball bearings because they are not designed to absorb high axial forces. Once more you must find the best compromise between backlash and friction. The correct adjustment is locked with an additional nut. The free ends of the threaded rods are guided by single ball bearings. The rod can still move in axial direction, but oscillations of those ends are eliminated. DC motors from old printers are the simplest drive configuration for this machine. Because of the low torque of those motors, a gear is needed as demonstrated in a previous video. It is made from a disc with 20cm in diameter and cut from 5mm plywood. To get it more circular, my drill press is used as lathe. Here you can see a motor with a rubber roll from a printer forming the second gear of the transmission. I will show a variety of electronics and motors in subsequent videos. The table of the machine is formed by 9 square tubes. Adjust all tubes in parallel to the router with the bolts and nuts. Another time-consuming process but necessary to get good results. When talking about results, here I am processing another test piece of aluminum with the low-tech configuration of the machine, now with a 3.2mm router bit. The pattern consists of a circle, a square and a triangle. The coolant is nothing but water and the circular flow is still in an experimental state, same as the software and the electronics. The router dives deeper into the metal with each run. Still not fast, but precisely. The result indicates that the mechanics is really solid without noticeable backlash. The router hits the trace of the previous one perfectly. Keep in mind that the CNC is still in an early state and there are many things to be improved over time. Have a look at the full resolution pictures of the samples on my project page or on Hackaday. That's where you can also find build instructions for making your personal copy of this machine. Thanks for watching and I'll be back.